Okay, for this video what we're going to do is we're just going to work the sample problem and get a feel for how to use the unit circle to evaluate uh, some basic trig functions with the angles that we should be familiar with. Now, it would be handy to, when you're working this problem, have this document in front of you. Hopefully by this time you've had the opportunity to fill this out at least once, and I would definitely take the time to pull a blank off Moodle and practice filling this in until you get comfortable with the patterns around the unit circle and understanding each of those. But at the time being, if you don't know it yet, just keep it in front of you as you work these particular problems. And so if we look at this, it says for us to find the value of sine of pi over 4. Now, we should know that this is the same thing as the sine of 45 degrees. Whichever way you decide to remember it is up to you. Now, if you remember that the sine of any angle on the unit circle is equal to the y value in the xy ordered pair. So we could simply pull the ordered pair off of the sine of 45 degrees, or the sine of pi over 4, and what we'll see is the ordered pair is given to us as the square root of 2 over 2 and the square root of 2 over 2. Now, if you remember from the previous part of the unit circle, that the y value makes up the sine, and so we can simply say that the sine of pi over 4 is going to equal to the square root of 2 over 2. So that would be our answer. Now, also keep in mind it said to leave answers in exact form, and so when we leave an answer in exact form, we leave it with the symbols in it as opposed to putting it in decimal form. So we'll go ahead and continue to do that for the rest of them. Same sort of pattern there. We've got the cosine of pi over 6, which is going to be 30 degrees. And we can simply, if we simply remember that the cosine of any angle was equal to the x-coordinate, and basically we just need to find what that is. Excuse me. Okay, and then so now we just need to identify the x-coordinate, and we'll have the cosine of pi over 6 equals to the square root of 3 over 2, and that's our exact value. Alright, now let's move on to the next two. Now we run into the cosine of 2 pi over 3, and if you don't remember specifically which one that is, that's where you would just come on in here and use this as a reference, and we'd work our way around to 2 pi over 3, which is also 120 degrees. Now, we also have to keep in mind that this is in quadrant 2 now, and we're being asked for the cosine, and in quadrant 2 the cosine is going to actually be a negative value, so we make sure that our final answer is in terms of a negative value. But we can see a couple things here. We can see 120 degrees, 2 pi over 3, and we also have the ordered pair that goes along with 2 pi over 3. So that's going to be some valuable information here. And so since we know that ordered pair is negative 1/2 and the square root of 3 over 2, and we also know that the cosine of any angle is the x value, then we can figure out the cosine of this is very simply 1/2. So we can say that the cosine of 2 pi over 3 is going to equal to negative 1/2. Alright, so that's pretty straightforward, first three samples. Now, the next sample takes us into a problem where we're at 135 degrees, but not only that, we're also looking at the tangent, and so we need to remember from the unit circle that the tangent is going to be equal of any angle is going to be equal to the y over the x value. And so when we look at the tangent of 135 degrees, we can go find 135, and we see that it is square root of 2 or negative square root of 2 over 2 and square root of 2 over 2, so it's in the 45 degree angle family. And so what we'll have here is we'll have the given x and y, and we know that the tangent is equal to the y over the x, which is going to give us the tangent of 135 degrees is equal to the square root of 2 over 2 divided by negative square root of 2 over 2. Now, for those of you who don't remember how to do this operation, you basically multiply it by the reciprocal, which creates a canceling out effect here, leaving us that the tangent of 135 degrees is actually going to equal to negative 1. Okay, so hopefully now you've kind of got the pattern and you can kind of see how to work with these things. Part E, we have cosine of negative 180. So the coterminal angle for negative 180 is going to be 180 degrees. So we can just as easily look at the cosine of 180 degrees just as easily, and that point is negative 1, 0. And of course the cosine was represented by the x value, and so we can say that the cosine of negative 180 degrees is also equal to negative 1. Last but not least, we get into secant, and if we look at secant of any angle, and that is going to be 1 over x, since this is the reciprocal of this cosine. So if we look at the 90 degree angle, the 90 degree angle has a point of 0, 1, and so we're going to take that x value and we're going to put it into this secant, and what you'll see is that we have 1 over 0, and we know that anything over 0 is undefined, so we could say that the secant of 90 degrees is technically undefined. And if you put that in your calculator, what you're going to get is basically an error message. It may even say undefined. So that's a good sample problem using a lot of the knowledge that you should be developing as you work with the unit circle, and you can see why this document here will become so important to you. And your ability to fill it in may help you answer other trig questions as you work problems throughout the unit and also on the unit tests. All right.